All right, y'all. So today we're going to start discussing how to solve quadratic equations by completing the square. This is one form algebraically of solving quadratic equations. So I wrote down all the steps that are in the book more compact, I guess, more shorter than the long explanation in the book. So these steps are from the book, just a shorter version of them. So step one, you want to isolate the variable terms, and step 2 and 3 kind of go together. That's why you have this note. After you isolate the variable terms, you want to transform the left side into a perfect square trinomial by dividing the coefficient of the x term by 2, then square it. So you take your b value, divide by 2, then square. And that value that you get when you simplify the b value divided by 2 and square it, you will add that side or add that value to both sides. Then you're going to solve the equation, and steps 4, 5, and 6 are how you solve the equation. You write the trinomial in factored form as a square of a binomial. Then you take the square root of both sides and solve for x and leave the solutions in positive negative form. Okay. And then we're going to discuss the vertex form. That way you know what the vertex form is in case you get asked a question about the vertex form on the LEAP test, which is very likely that you will see vertex form on the LEAP test. Okay. All right. So on your notes, I wrote in this example for you, and I'm going to rewrite it, but I'm going to go step by step. So everything that I write on here is already on your notes. If you are in class, VIP students, you do not have a copy of this. So you're going to want to either print this and write it out or save a copy of this PDF. Okay. So the example, solve x squared plus 10x minus 6 equals 0 by completing the square. So I have x squared plus 10x minus 6 equals 0. I'm just rewriting it so that I can have my problem. And step one says you need to isolate the variable terms. So step 1 is I'm going to isolate my variable terms, x squared and 10x, by adding 6 to both sides of my equal sign. I want to isolate, which means get by itself. Variable terms, my terms with my variable, in this case, my variable x. And by doing so, I have x squared plus 10x equals 6. This is step number 1. Step number 1. Step number 2, we're going to step away from that trinomial for a second. Well, this equation for a moment. And what is my b value? Well, my b value from looking at my original trinomial is positive 10. So b is positive 10. And I'm going to divide that coefficient of my x term by 2 and square it. So I'm going to take positive 10, divide by 2, and square. And what do I get when I divide 10 by 2? I get 5. And what is 5 squared? 5 times 5 is positive 25. So this is the value that I'm going to add to both sides of my equal sign. Okay? So step number 3, I'm going to go back to my original problem up here, step number 1. Let me go back to step number 1, and I'm going to add 25 to both sides. I'm going to add 25 to both sides. And when I add 25 to both sides, I'm going to just simplify this, x squared plus 10x plus 25. I'm going to combine 6 and 25 to 31. And step number 4 says to write the trinomial in factored form as a square of a binomial. So I'm going to write this trinomial as a square of a binomial. Well, you should know, thinking back to our factoring unit, this is a perfect square because what's the square root of 25? Well, the square root of 25 is positive negative 5, right? Positive negative 5. I need to add to get positive 10. So is negative 5 minus 5 positive 10? No, positive 5 and positive 5 is positive 10. So positive 5 times positive 5 is positive 25. Positive 5 plus positive 5 is positive 10. So I know that my perfect square binomial is x plus 5 squared. This is going back to your perfect square factoring if you need to go back and refresh your memory. You take the square root of your c value. Square root of your c value is positive, negative, that square root. Figure out if you need the positive or the negative based on your sign of your b value. So now I have x plus 5 squared equals 31. Step number 5 says you need to take the square root of both sides. Now, when you take the square root of x plus 5 in parentheses squared, the square root of 31, when you take the square root of a square value, your square root and your square value cancel each other out because the square root of anything squared is what's left inside underneath that root, okay? So you end up getting x plus 5 equals positive negative square root of 31, because we know that when we take the square root of something, it becomes positive negative that value, okay? Now, in order to simplify this, I'm kind of running out of space here, so I'm gonna just rewrite it up here. On your page, I had enough space. Okay, so I'm just gonna rewrite this x plus 5 equals positive negative square root of 31. Okay, now in order to solve for x, I need to subtract 5 from both sides. So x ends up being negative 5 plus or minus the square root of 31. And the square root of 31 is not a perfect root. So you're just going to leave your answer as x equals negative 5 plus or minus the square root of 31. So this means that x equals negative 5 plus the square root of 31, and x equals negative 5 minus the square root of 31. You actually have two solutions here. You just write it with this positive negative. This means plus square root of 31 minus square root of 31. So you still have two solutions. Okay, now the vertex form of this equation, if you go back to step number 4 here, where you have the perfect root, or the perfect square binomial set equal to a value. If you take this, y would equal x plus 5 squared minus 31. You would subtract 31 from both sides. This is the vertex form of this quadratic. You subtract 31 from both sides to get the perfect square binomial minus your k, or plus your k. In this case, k is negative 31 plus k. Now, I'm not going to have a coefficient because my a value in my original is positive 1. But if your a value in your original quadratic is anything greater than 1, you would write that a value here. But typically, almost all of yours are just going to be positive 1 anyway. Okay? So now I'm going to open up the assignment, and I'm going to do a few assignments for you, a few problems for you. Okay, number 1. Let's look at number 1. I have p squared plus 14p minus 38 equals 0. So I'm going to first isolate my variable terms by adding 38 to both sides. I want to add 38 to both sides. Okay, so my isolated variables, p squared plus 14p, is set equal to positive 38. I'm going to take my b value, which is 14. Let me take that b value. So b divided by 2 squared equals 14 divided by 2 squared, which ends up being 7 squared, which is 49. So I'm going to take that 49, and this is the value that I'm going to add to both sides. So I'm going to have p squared plus 14p plus 49 equals 38 plus 49. Okay, now I'm going to find the perfect square binomial for p squared plus 14p plus 49. I know the square root of 49 is positive negative 7. The square root of 49 is positive negative 7. So I need to add to get positive 14. So that tells me that my value needs to be positive 7. 7 times 7 is 49. 7 plus 7 is 14. So my perfect binomial squared is going to be p plus 7 squared. This is probably the point where y'all are all going to struggle if you didn't understand perfect square binomials back in the factoring section. So p plus 7 squared equals 87. Now you're going to take the square root of both sides. And remember, when you take the square root of both sides, the root and the square cancel each other out. And you're left with p plus 7 equals positive negative square root of 87. Then I'm going to subtract 7 from both sides. I'm running out of space here. When I subtract 7 from both sides, I'm just going to rewrite it here. You end up getting that p equals negative 7 plus or minus the root of 87. And that is your answer. So your two solutions is negative 7 plus the root of 87 and negative 7 minus the root of 87. And then over here to the side, I want you to add this step. What is the vertex form? What is the vertex form? Actually, I'm going to write this out for those of you that want to take a picture of this. What is the vertex form? The vertex form, I'm going to go back to this point here. Well, I kind of wrote over everything. The vertex form ends up being the p plus 7 squared minus 87. Y equals p plus 7 squared minus 87. It comes from step 4 right here before I wrote the roots. P plus 7 squared equals 87. You subtract 87 from both sides. So y equals p plus 7 squared minus 87. That is the vertex form. I should have wrote vertex form in blue. Vertex form. There we go. Okay. Number 2. Number 2, I'm going to isolate my variable terms by adding 59 to both sides. Add 59 to both sides. And that gives me v squared plus 6v equals 59. What is b divided by 2 squared? Because that's the value that's going to give me to add to both sides? Well, b was 6. So 6 divided by 2 squared is 3 squared, which is 9. So that tells me I need to add 9 to both sides of this equation. So v squared plus 6v plus 9 equals 59 plus 9. Don't forget to add your value to both sides. A common mistake is students write the value and make your perfect trinomial, but then you forget to add the 9 to the right side. Okay, so v squared plus 6v plus 9. What's the square root of 9? The square root of 9 is positive negative 3. I need the positive 3 because 3 plus 3 is 6. Positive 6. So v plus 3 squared. V plus 3 squared equals 68. And I'm going to take the root of both sides, and I'm going to rewrite this so that I can use that section when I go to write the vertex form. We take the square root of both sides. When I take the square root of both sides, remember the root and the square cancel each other out. And that leaves me with, let me rewrite it up here, v plus 3 equals positive negative the root of 68. I'm going to solve for the value b by subtracting 3 from both sides. So v is negative 3 plus or minus the square root of 68. And those are your two solutions, negative 3 plus the root of 68 and negative 3 minus the root of 68. Those are your two solutions. The vertex form, we're going to go back here to our step number 4. The vertex form, I'm going to subtract 68 from both sides. I'm going to subtract 68 from both sides. So the vertex form is y equals v plus 3 squared minus 68. That is the vertex form. Once you get your perfect square binomial set equal to a constant, that is the step that you go back to write your vertex form. Because if you look at the vertex form in your notes on the back of the page, you will see that it's the x plus, x minus h squared plus k. Okay, so this is in that form. All right, number 3. If you feel confident at this point, pause the video and see if you can do number 3 on your own, and then come back and watch and check your work. And if you got the answer correct, then you can move on to number 4. If not, then you can pick up on the video where you are and watch and see where you made your mistake. Okay. Number 3. I'm going to isolate my term with my variables by adding 51 to both sides. Add 51 to both sides. So I've got a squared plus 14a equals 51. What is your b value? Because I need my b value to divide by 2 and square to see what I need to add to both sides. My b is positive 14. So what is 14 divided by 2 squared? This should look familiar if you look at the problem directly above you. 14 divided by 2 is 7 squared. And what is 7 squared? It's 49. So 49 is what I need to add to both sides of my equation. So I'm going to go back to the step 1. A squared plus 14a plus 49 equals 51 plus 49. Add it to both sides. Again, this is a common mistake. Don't forget to add to the right side of your equation. Now the square root of 49 is positive negative 7. I need positive 14, so I'm going to use positive 7. A plus 7 squared equals 51 plus 49, and 51 plus 49 is 100. And what is the square root of a plus 7 squared? And the square root of 100? My square roots are going to cancel with my square and leave me a plus 7 equals, what's the square root of 100? Well, the square root of 100 is 10, but don't forget it's positive negative 10. 10 times 10 is 10. Negative 10 times 10 is, or let me back up a little bit. Positive 10 times positive 10 is positive 100. Negative 10 times negative 10, negative times a negative is a positive. So that would be positive 100. That's why it's positive negative, the constant, okay? So your answer here, I'm going to rewrite this up here since I ran out of room again. A plus 7 equals positive negative 10. So what that means is that you're going to have two answers, just like the previous ones, but you're not going to have a root in your answer. So A equals, you're going to subtract 7 from both sides. A equals negative 7 plus minus 10. So A equals negative 7 plus 10, and A equals negative 7 minus 10. What is negative 7 plus 10? Negative 7 plus 10 is going to be positive 3. And negative 7 minus 10 is negative 17. So your answer is A equals 3 and A equals negative 17. Okay? The vertex form, I'm going to change to blue here. The vertex form of that equation, I'm going to go back to this step here. I'm going to subtract 100 from both sides. So the vertex form is y equals a plus 7 squared minus 100. That is the vertex form. That is the vertex form. Okay, number 4. Again, try to pause the video and work it out yourself before you just get the answer. Okay, number 4, I'm going to isolate the variable terms by subtracting 11. X squared minus 12x equals negative 11. I'm going to divide my b value by 2 and square. My b value in this case was negative 12 divided by 2 squared. What's negative 2 divided by positive 2? Negative 12 divided by positive 2 is negative 6. And what is negative 6 squared? Positive 36. That is the value that I add to both sides. So I've got x squared minus 12x plus 36 equals negative 11 plus 36. Square root of 36. Square root of 36 is positive negative 6. I need to add to negative 12. So this is the first one where we've had minus 6 because minus 6 is negative 12. So my perfect square binomial is going to be x minus 6 squared. Again, if you need extra help on this, go back to the perfect square factoring section. And negative 11 plus 36 is going to be positive 25. Take the square root of both sides. When I take the square root of both sides, the root cancels with the square. I'm going to bring this up here. And I'm left with x minus 6 equals the square root of 25 is a perfect root. It's positive negative 5. I'm going to add 6 to both sides. So then x ends up being 6 positive negative 5. So x is 6 plus 5, and x is 6 minus 5. 6 plus 5 is positive 11. 6 minus 5 is positive 1. So for number 4, your x is equal to 11, and x is equal to 1. Two solutions. X is 11, and x is 1. Your vertex form, going back here to step 4, your vertex form is y equals x minus 6 squared minus 25. Because remember, I have to subtract 25 to the left side. So that is your, vertex form. Kind of wrote over that a little bit. Okay. Number 5. Again, try to pause the video if you can. Try to pause the video if you can. All right, I'm going to isolate the variable terms by subtracting 8 from both sides. So I get x squared plus 6x equals negative 8. I'm going to do b divided by 2 squared to figure out what I need to add to both sides. B is 6. 6 divided by 2 squared. 6 divided by 2 is 3 squared. 3 squared is 9. So I need to add 9 to both sides. So x squared plus 6x plus 9 equals negative 8 plus 9. X squared plus 6x plus 9, the square root of 9 is positive negative 3. This positive 6 tells me that I need positive 3. X plus 3 squared equals negative 8 plus 9 is positive 1. Take the square root of both sides. Okay, I'm going to come back up here. I'm going to just carry this up here. Taking the square root cancels out the root and the square. So that leaves me with x plus 3 equals the square root of 1, and the square root of 1 is just positive negative 1. I'm going to subtract 3 from both sides. So what that tells me is that x is negative 3, positive negative 1. So x is negative 3 plus 1, and x is negative 3 minus 1. Negative 3 plus 1 is negative 2, and negative 3 minus 1 is negative 4. So your answers are x equals negative 2 and x equals negative 4. Your two solutions are negative 2, negative 4. All right, number 6. Oh, I didn't write the vertex form. Vertex form. I'm going to use step 4 here. X plus 3 squared equals 1. So the vertex form is y equals x plus 3 squared minus 1. That is the vertex form. All right, number 6. I'm going to add 3 to both sides to isolate the terms with the variables. N squared minus 2n equals 3. Take my b value, divide it by 2 and square. My b value was negative 2. So negative 2 divided by 2 squared. so many 2's. Negative 2 divided by 2 is negative 1. Negative 1 squared is just positive 1. So I'm going to add 1 to both sides. And I'm going to make n squared minus 2n plus 1 to a perfect square. The square root of 1 is positive negative 1. Okay. Square root of 1 is positive negative 1. And if I take the square root of square root of 1 and get positive negative 1, that tells me I'm going to need the minus 1 because negative 1 minus 1 is negative 2. So n minus 1 squared equals 4. I'm going to take the square root of n minus 1 squared and the square root of 4. Those cancel each other out. And I'm left with n minus 1 equals positive negative 2 because the root of 4 is positive negative 2. I'm going to add 1 to both sides. When I add 1 to both sides, that tells me that n is 1 positive negative 2. So n is 1 plus 2, which is 3. And n is 1 minus 2, which is negative 1. So the solution for the quadratic of number 6 is negative 1 and 3. N equals negative 1, n equals 3. The vertex form is y equals n minus 1 squared minus 4, because I have to subtract the 4 to the left side. And again, all of these, I'm going to zoom out for a minute. The vertex form, remember, is a times x minus h squared plus k. If you look at the a value for all these quadratics, it's positive 1, positive 1, positive 1, positive 1, positive 1, positive 1. Therefore, my coefficient for my a value in the vertex form for all these are just positive 1. Okay? So pay attention to your a value in regards to that reason. Okay, let me zoom back in. Because I think I put 1 on here that was not, or there's one on your Edulastic assignment where a is not 1. I believe a was negative 1. So just pay attention to your a value. All right, number 7. Again, pause the video and see if you can do it on your own. Then come back and check. Isolate the term with the variable by adding 15. So x squared plus 14x equals 15. B divided by 2 squared. We're back at 14. We've already done this one twice. 14 divided by 2 was 7. 7 squared is 49. So x squared plus 14x plus 49, that's the value that you add to both sides, equals 15 plus 49. And we've already done this twice. We know that to get positive 49, we multiply positive 7 and positive 7 and add 7 and 7 to get positive 14. So x plus 7 squared equals 15 plus 49. 15 plus 49 is 64. Okay, I'm going to take the square root of x plus 7 and the square root of 64. The square root and the square cancel. Leaves me with x plus 7 equals the square root of 64. I know, I didn't mean to make that little mark there. I know that the square root of 64, the square root of 64 is 8. So that's positive negative 8. To isolate x, I'm going to subtract 7 from both sides, and that tells me that x equals negative 7 plus or minus 8. So x equals negative 7 plus 8, which is 1. and x equals negative 7 minus 8, which is negative 15. So x, the two solutions for this quadratic is x equals 1 and x equals negative 15. Okay, for the vertex form, I'm going to go back to step 4. Subtract 64 from both sides. So the vertex form ends up being y equals, my a is 1, x plus 7 squared minus 64. All right, number 8. Isolate the terms with the variables by subtracting 23 from both sides. When I subtract 23 from both sides, I get k squared minus 12k equals negative 23. Take my b value of negative 12, divide by 2 and square. Negative 12 divided by 2 is negative 6 and square. Negative 6 squared is positive 36. So this is the number that I'm going to add to both sides. I'm going to add 36 to both sides of my equation. What's the square root of 36? Square root of 36 is positive negative 6. I need the negative 6 since I'm adding the negative 12. So k minus 6 squared equals negative 23 plus 36 ends up being 13. Take the square root of k minus 6 squared, square root of 13. Square root and square cancels, leaves you with k minus 6 equals positive negative the root of 13, because the root of 13 is not a perfect root. Add 6 to both sides, and you get k equals 6 plus minus the root of 13. So your two solutions is 6 plus the root of 13, 6 minus the root of 13. And then the vertex form, going back to step 4. The vertex form is y equals, my a value is 1, so I'm just going to leave it with 1, k minus 6 squared minus 13. All right, number 9. If you look at number 9 on your paper, you'll notice something a little different than numbers 1 through 8. Numbers 1 through 8, if you look at your page, they were all trinomials set equal to 0. Well, if you look at number 9, I have a trinomial set equal to a constant of 7 instead of 0. Not going to change a whole lot. The only difference is that when you add 91 to both sides, you would have to add 91 to 7 instead of 0. So we end up getting r squared minus 4r equals 7 plus 91, which is 98. The only difference is you would combine those two constants, whereas before you were just adding to 0 and ended up being the value that you added to both sides or subtracted. Okay, so now I have b, which is negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2 squared, which ends up being 4. So I need to add 4 to both sides. R squared minus 4r plus 4 equals 98 plus 4. The square root of positive 4 is positive negative 2. This negative 4 tells me that I need negative 2, so r minus 2 squared equals 98 plus 4. 98 plus 4 is 102. Take the square root of r minus 2 squared the square root of 102. Those cancel and leaves me with r minus 2 equals positive negative the root of 2, because the root of 2 is not a perfect root. Add 2 to both sides. So r is 2 plus or minus the square root of 102. So the solution is 2 plus the root of 102, 2 minus the root of 102. Those are the two solutions. The vertex form, going back to step 4, right here, my a is 1. So my vertex form is y equals a, which is 1, times the variable minus h squared plus k in this form by subtracting 102 to the left. Right, number 10. I have the variables. In order to isolate the variables with my, or terms with my variables, I need to subtract 26 from both sides. Again, just like number 9, I don't have a 0 as my constant. So I'm going to have x squared minus 10x equals 8 minus 26, and 8 minus 26 ends up being negative 18. My b value is negative 10, so negative 10 divided by 2 squared equals negative 5 squared, which ends up being positive 25. So x squared minus 10x plus 25 equals negative 18 plus 25. Square root of 25 is positive negative 5. This negative 10 tells me that I need negative 5. So x minus 5 squared equals negative 18 plus 25. And when I combine negative 18 and 25, I get positive 7. Take the square root of x minus 5 squared, the square root of 7. The square root and square cancels and leaves me with x minus 5. Equals positive negative the root of 7. Add 5 to both sides, and you get x equals 5 plus or minus the root of 7. Those are your two solutions, 5 plus the root of 7, 5 minus the root of 7. And then the vertex form, coming back to step 4, the vertex form is y equals, a is 1 still, x minus 5 squared minus 7. All right, so that concludes completing the square. I went ahead and eliminated 11 and 12. So omit 11 and 12 for you VIP kids. Do not do those. Face-to-face kids that got a hard copy, I just whited them out on your copy. So you don't even have an 11 and 12 on your copy.